Okay, so here is the solution to problems 32 through 44, not including everyone, just including the ones I'm assigned. So start off simple, then we get more complicated. So problem 32 says let P represent 16 is less than 8. Let Q represent the statement 5 is not equal to 4. And let R represent the statement 17 is less than or equal to 17. Actually, what we're going to do is we're going to do it slightly differently. We're going to make the whole truth table, and then we're going to pick out which one this represents. So this is P, Q, and R. So we have 8, and then we need, let's see, 32, we need 1, 2, but let's write it down here. I'm getting ahead of myself. So the statement we're looking at is P or not Q. And actually, we'll make up a table. We won't do every one of them, but we'll do the one that's important. So we're going to make it 2, and then we need 1, 2, 3, 4, 5 columns. So let's explain why that is. So there's 2 ways of doing these truth tables, and this is the second way of doing it. So the first thing you always do is populate it with the statements that are involved, P and, in this case, P and Q. So we don't do the not Q except in this part here. So then this is just P and Q by themselves. So it was P, Q, and R. It's always the positive versions of the things. Then you have P, and then you write the statement out. The parentheses, well, there is no parentheses, so get rid of the parentheses. So you have P or not Q. And statement P is 16 is less than 8. That has a certain truth value to it. And the truth value is it's false because 16 is not less than 8. So that's not a true statement, it's a false statement. And then we have Q, which was represented by the statement 5 is greater than, or is not greater than 4, which is also false because 5 is greater than false. So if you said 16 is greater than 8, that would be a true statement. But 16 is less than 8 is a false statement. Also, the opposite of this is if said not greater than. So if you said 5 is greater than 4, then you say that would be a true statement. Okay, but the statements as given in the problem are false statements. So that's the truth values you put up here. So it's false, false. Then you fill in the value, the truth values for the P and the not Q, and then you use the OR comparator to find out the final answer. So here, if P is false, then P is false still. If Q is false, then not Q is true. And then we have the OR statement. An OR statement is false only if they're both false. So this is false, this is true. So using the truth tables for a OR operation, this is going to end up being true. So that's your final answer, is true. Okay, let's look at 35. 35, we have 3 statements, P, Q, and R. And then we have this logic statement which says P and Q or R. So to figure out how many columns we need, we figured how many letters we have, P, Q, and R. Here we had 2, P and Q. So we need 3 columns for just the letters, and then we need the additional columns for the to write out this logic expression, which is 1, 2, 3, 4, 5. So this 5 plus 3 is 8. So we need 8 rows, and we just need 8 columns and 2 rows. So like on the last one, we have P and Q, but we also have R. And then we write out this logic expression, but you can group the parentheses because those are just used for kind of grouping things together. So P and Q or R. Now, again, from the previous one, we know that P is false. The P statement is false, and the Q statement is false. And in this case, R is that 17 is this, to 17, which is true. So that 17 is equal to 17. So you populate these columns with what we have in the problem statement. Then you take these and you just copy them over if there's a not, if there's just this plain letter. If there was a not, then we change false to true and true to false. So P is false, Q is false from here, R is true. You do the AND operation first. So P and Q, for this to be true, both of them have to be true. So because they're both false, it's definitely false. And then what you do is you compare this truth value with that truth value using the OR operator. So we have false as a result of this operation. We have true because it was given to be true. And an OR statement is true if both or one of the two truth values is true. So we have false true, so that for an OR statement that's true. And that's your final answer. Okay, next we have 38, which is the last one in this section. Then we'll start to do complete truth tables, which is really what you need to know how to do. So for 38, we have the negation of P or the negation of Q or the negation of R. So again, we have three letters, P, Q, and R. We don't worry about the not statements at this point. So we need three columns for the P, Q, and R. And then the number of columns we need to write this whole thing out. We need one for that, we need one for that, one for that, one for that, one for that, and one for that. This negation here is negating everything that's inside that parentheses. So 1, 2, 3, 4, 5, 6. So we need 6. So we need nine columns. So we're going to make 1 2 by 5. Squish that down a little bit. And then we're going to clone that and then combine these two together with a little bit of overlap. Okay, so let's fill it out. Just like here, P, Q, R. This negation goes there. Parenthesis we include in there. Or not Q, the second parenthesis. So these are all go together. Or not R. We know from the previous problem that for this particular problem, P is false, Q is false, R is true. First thing we do is we either fill in the column with P or not P or Q or not Q. So P is false, so we copy false directly. Q is false, so the negation of Q is true. R is true, so the negation of R is false. So we just, when we get the negation, we change them from these values over here. Okay, the first thing we do is we do this operation because it's inside the parentheses. We have an OR statement. So for an OR to be true, just one or both of these have to be true. So we have one of them is true. So the result is true. Now the next thing we do, this negation is on the outside of the parentheses. So we actually do this next. And so we're taking the negation of the result of this operation. Well, the result was true, so this is false. And then ultimately you compare this value, which is the result of everything on this side, with the right-hand side. So they're both false. This negation of this whole thing is false, and this is false. So the answer, the final answer goes here, which is false. Okay, now we get into the more, actually just says give the number of rows in the truth table for each compound statement, which is easy. So the number of rows is dependent upon the number of letters. So you basically take the number of letters raised to the power. Typically it's either 2 or 3. Okay, so all I have to do in this case is count the number of letters in the statement. So let's just go ahead and write it out. Okay, I think I got that right. I think I included too many parentheses, but you know, it looks very complicated. But in this case, they're just looking for the number of rows. And so what we have is we have a P, we have a Q, we have an R, we have an S. That's 4. So actually it's 2 to the nth power. 2 to the nth power. In this case, n is 4, so you get 16. You need 16 rows. Okay, and the final one for this group, 44. Oh man, I'm not going to write it out. You can look it up in your book. So I'm just going to go through P, Q, R, S, M, N, U, V. Okay, so that's 2 to the 8th power. There are 8 letters. That's equal to 256. Obviously, we're not going to do anything that complicated. You know, you probably use a spreadsheet to try to minimize the amount of work you have to do.